Hello students, today let us solve a problem. So here in the question they say that a heat engine transfers heat at a rate of, so they have given the rate at which the heat is transferred, that is 100 MW from a furnace. So if the heat is rejected at the rate of 35, then calculate the net power output and the thermal efficiency of this engine, that is heat engine. So for the solution, first of all we will write down the given data. So what is the given data? So they have given the rate at which the heat is transferred. So that is 100, and the rate at which the heat is rejected is 35. Now they are asking us to calculate the power output, that is capital W, power output. That is, we will get it by the difference between the heat transfer, that is the heat engine transferring the heat at a rate, and rejection, that is accepting and rejection, that is QH minus QL. So that is 100 minus 35, which will give us 65 MW. Okay, so this is in watt. Then they are asking us to calculate the thermal efficiency. So for the thermal efficiency, we write it as eta, that is power output divided by the heat entering into the furnace, or the heat engine transfer rate. So that is given by 65 divided by 100. So which will give us 0.65%. So the thermal efficiency of the heat engine is 65% or 0.65%. Now to draw the diagram, so if this is the furnace, the heat entering inside is QH into the heat engine. This is the heat engine. This will give us the net power output, and then the heat which is leaving the, or which is rejected by the heat engine, is given by this, and this is the river to which the heat is rejected. So we can represent it with the help of this diagram.